Hello. Today we're talking about potential and kinetic energy. Both of those things are energy, so the first thing we need to look at is what on earth is energy? Well, energy is the ability to cause change. Everything in this world except feelings and ideas is made up of energy or matter. Energy doesn't have mass or take up space. So, which of these examples below are energy? If you look right here, air has a mass and it takes up space. We've talked about that before. Air is matter. It's got atoms in it. That's what we breathe. Oxygen, carbon dioxide, any kind of gas could be floating around in the air. So air is not energy. Now light, on the other hand, doesn't have a mass and it doesn't take up space. We see it though. Light is energy. Love matters. We love love. But love is not matter or energy. Love is a feeling. Atoms have a mass. They take up space. They are matter, not energy. Last but not least, and you can't see it, it's under my little face right here, we've got heat. And now heat is an energy. Heat doesn't have a mass and it doesn't take up space, but we sure can feel it on a cold day, especially if we're standing by a campfire or something along those lines. So heat is energy. So heat and light of these listed below are both energy. Yesterday we learned about potential energy, and potential energy is energy that's stored in matter waiting to be released. Some great examples of potential energy are if someone has a bow and an arrow, the arrow, whenever they pull that bow back, the arrow being stretched before it's released. So they're standing there ready to let it go. That's a great example of potential energy. And then you see right here, this man holding the big rock up. That rock has a lot of mass and he's lifted it up off of the ground. That has a lot of potential energy in it. Food for our bodies is another great example of potential energy. Before we eat it, that food carries the potential energy. Once we eat it, our bodies turn it into energy that we need for motion. So then we turn it into something else. The next great example for potential energy is gasoline. So if you have fuel for your car or truck, gasoline is a great example of potential energy. It's got all kinds of energy stored in it, and our cars, our vehicles turn that into energy for motion, for kinetic energy. What similarities do you notice about all these examples? So next we've got kinetic energy. We talked about this yesterday with our jumping jacks and everything. Kinetic energy is the energy of motion that's released from stored energy. So the potential energy that we just talked about, let's talk about our examples of this. So we had the bow pulled back while they were sitting there holding it. That was potential energy. Well, once they let it go, that arrow is flying through the air. It's in motion, so that is kinetic energy. Here we've got an object rolling down a hill. He's moving down, and you can tell he's moving down. That is kinetic energy because that bicycle is in motion. Here we've got muscles moving. So these folks ate the food that we looked at on the last slide, and now they're using that energy for motion. They're in motion, so that's kinetic energy. And here we've got a car moving. There's gasoline in that vehicle. That's why it's able to go down the road. What similarities do you notice about all of these examples? Hopefully here you said they're all in motion. And hopefully the slide before you said that none of them are moving. The potential is there for movement, but they're not moving yet. So potential and kinetic energy. Energy can change from potential energy to kinetic energy. That's a really cool thing about potential and kinetic. We've got some examples right here. We've got a yo-yo, and here up at the top when you hold a yo-yo, surely everybody's seen a yo-yo before. When it's at the top, you've got potential energy, but whenever it starts moving down, the kinetic energy is what the energy is changing to. When it goes back up, you get more potential. The higher up it is, the more potential you have. The closer it's moving to the bottom, the more kinetic energy you have. Here we've got a bicycle moving up the hill, and the higher up the hill the bicycle goes, the more potential energy it has. Right here at the top of this hill, this is the most potential energy this bicycle is going to have. And when he starts going down the hill, that potential energy is turned into kinetic energy, the energy of motion. Here we've got the same thing. We've got a roller coaster. He's starting at the top of the hill and he's going down, and in this one you can see as he moves, the potential energy here is really high up at the top. When he goes back up, oh, look at that, it was all the way up at the top. Right here we've got kinetic energy, and if you look as he gets closer to the bottom, right here, that kinetic energy is almost all the way to the top. Pretty cool, right? It just transfers from one to the next. So height is not the only way for potential energy to change to kinetic energy. Can you think of anything else that might change? So molecules store energy in their bonds, which can be broken down to release energy. And this is happening to you right now as the food you've eaten is going through a chemical change to release that energy. So this morning I had a piece of banana bread and a cup of coffee for breakfast. So my breakfast is turning into energy that I need right now to move around and teach y'all. What did you have for breakfast this morning? Whatever that was is what your body's using for the energy you need to get through this day. And if you're one of those that tells me that you didn't have breakfast this morning, I'm going to tell you, you should have breakfast. It's good for your body. You got to have that energy. We need it. So right down here, this says that when you eat, your digestive system breaks down food into molecules that are sent to every cell in your body, where they're broken down to release energy that you need to live. On this side, we're going to talk about cars and the gasoline that they need. So if you think about the breakfast I had, is what my body turned into energy that I needed to move. My car doesn't have breakfast. It uses gasoline, which is food for the car. So when your vehicle burns gasoline, the molecules break down and release energy and burning to give the car what it needs to move. So I think this slide right here is really cool. This is the energy that's in food. So food can be measured by the amount of energy it has. For example, a piece of buttered toast has about 315,000 joules of energy. With that amount of energy, we could jog for 6 minutes, we could ride a bicycle for 10 minutes, we could walk briskly for 15 minutes, or we could sleep for about an hour and a half. We could run a car for 7 seconds with 315,000 joules of energy. At 50 miles an hour, wow, that's pretty fast. We could light a 60-watt light bulb for about an hour and a half. We could lift a sack of sugar from the floor to the counter 21,000 times just from the energy we got from eating a piece of buttered toast. Pretty crazy. So right here, it says if you ate 5 pounds of spaghetti, well, the energy found, rather, in 5 pounds of spaghetti could brew a pot of coffee. The amount of energy in one piece of cherry cheesecake can light a light bulb for an hour and a half. And right here, we've got a Big Mac. Oh, I'm sorry. If you eat 217 Big Macs, the amount of energy there could drive a car for 88 miles. That seems crazy to me. Big Macs must have a bunch of energy. There's some questions below. Go ahead and answer those questions. And there's a little thing for you to play with roller coasters. So go ahead and play around with that whenever you get to it. Answer the questions. Watch the video at the end. Make sure you answer the questions the correct way. There's no excuse for a 0 on this assignment because I'm giving you all the answers in the last video. Okay? Y'all are amazing. Have a wonderful day.